I think we'll get started. We'll probably have a few more people come in that went downtown Davenport. For those of you who actually read the invitation, thank you. Again, we're very pleased to have Russell and Shive host us today. We really appreciate all the hard work you put into this, so we're looking forward to this. It's going to be a great day. Just a couple of housekeeping things. Again, we like to, one of our sponsors is Northwest Bank. We'd like to acknowledge them. Corey's here, those guys. And then also, we're sponsored, the Quad City Innovation Hub is sponsored by the grant from the Defense, the DIA, the Defense Department. So again, we want to thank them for their help with this. At this point, we'll, if we could, just quickly go around the room. Again, for those who I haven't met, my name is Lynn Frias. I'm a consultant with the Chamber of Commerce working on the Quad Cities Manufacturing Innovation Hub. So we're here to support small, medium-sized manufacturers, improve today's operations, as well as prepare for the technology tomorrow. And it's our presentation. So I'll let you guys wait and start.
I'm Chris Nicknish. I'm with Kalachi Construction in Business Development. We're out of Iowa City, Iowa.
I'm Mike Ocean. I'm with Ocean Incorporated. We're the ice manufacturer out of Davenport.
Carly Evans with Paragon Commercial Interiors.
Marty Mayers with KBF Quad Corporation in East Moline.
Good morning, Danny Emerson, Architectural Products with All Steel in Muscatine, Iowa.
Morning, I'm Jay Gooden with Russell. I'm Corey Satterfield, building side team leader for the Shive-Hattery office here in Moline and industrial squad leader for that office as well.
Jason Denskin, BIM coordinator with Shive-Hattery.
John Pop, BIM coordinator, Shive-Hattery.
I'm Joe Reagan with Davenport City Schools, the project manager.
Kelly Young, Russell.
Lee Murdoch, Russell, project manager.
Lucas Boyle with Russell.
Amy Cook, Handicap Development Center.
Scott Pitting, Handicap Development Center.
Good morning, everyone. I'm Doug Flatterberg. I'm with the Lang Sign Group. We're a family-owned full-service sign company here in the Quad Cities.
Good morning, Monty Peterson. I'm with the CDA Group, which is basically a business consultancy that works with small and middle-sized businesses on organizational effectiveness.
I'm John Daly in Business Development with Russell.
Is that right? Project engineer with Russell?
I'm Joel Purcell with Russell in the project management area.
I'm Grace Gunlack with Russell.
Hi, I'm Jeff Van Hersel with IH Mississippi Valley Credit Union. I'm the facilities manager.
Brian Harry, Senior Project Manager at Russell, getting to build Jeff's new corporate headquarters for IH.
Corey Martin, Commercial Banker at Northwest Bank US. Kurt Pendleton, Project Manager at Russell.
Trevor Stoltz, Project Manager at Russell.
Ashley Willer with Russell.
Kwame Piso, King Fan with Rosa.
Craig Mons, I'm with Modern Piping.
I'm Brandon Buster. I'm with Lee Agency. We're out of Muscatine, Iowa, and I specialize in business insurance for manufacturers and contractors.
Thank you all. Matt Reaver with Russell. Then next, I'd like to introduce our two presenters, Rebecca Frangipane from Director of Virtual Construction at Russell, and Rebecca Jourdan, who's interior design at Shive-Hattery. And you have some bios on your mats in front of you, so you can refer to those. Again, I'll turn it over to you. Thank you.
All right, thank you for the introduction, Lynn. And we realize it might be really hard to remember our names or confusing which one we are. So Becca 1 and Becca 2, so thank you all for coming out so early in the morning to listen to us speak today on how we use technology and virtual reality within the built environment. We're excited to be here and present with you. Also, special thanks to Jason and John over there. They'll be helping with a live virtual reality demonstration, and they help a lot making the examples for this presentation. So we'll dig right in here. So today we'll be going over what virtual reality is, kind of the history of that and how it's evolved into the built environment. the impact on the design community, how we're using it to get buy-in from the clients, from communities, and also the live virtual reality demonstration where we'll be picking design options for our truck warehouse. And then we'll lead into the impact on the construction community, including field uses, scheduling, and operations of maintenance items. Then last but not least, we'll be talking about some other cool visualization tools and where we see the industry going. So what is virtual reality? On the back of your placemat, there is a glossary of terms, so I'm just going to read it. Virtual reality is a computer-generated simulation of a three-dimensional image or environment that can be interacted with in a seemingly real or physical way. So what I personally feel is that real or seemingly or physical way is the real importance here. So you really get a sense of how the space is going to feel. You feel like you're there. You're in your office with a headset on or on your couch with your phone up to your face, but you feel like you're in a different dimension. So I think that's the real importance, is getting a sense of that real experience. So like I said, you're on your couch with a headset. Hopefully you guys have kind of seen some of those headsets, or maybe you even experienced it. But I would like to tell you about my first virtual reality experience. It was on my 8th birthday. And my mom took us to the mall. Now this is when people actually shopped at the mall, so it wasn't empty like this. But there was a bunch of kiosks in the center and games that you could play. Since it was my birthday, my mom decided to splurge, and I got to play in the virtual reality pod. So this monstrosity was this huge thing, especially to an 8-year-old, but have since done some research, because I'm a nerd like that, and learned how this works. So the base of it was actually so large because there was actually magnets in there, and that's how it was tracking the movement of the headset. And they ran between $40,000 and $60,000 back in the early 90s. So I stepped in and put on the headset. Now this thing weighed 8 pounds, and I feel like I remember the attendant to the game like holding it up on my head. But I gotta go ahead and shoot down Space Invaders. So I'm sure the graphics looked something like this, but I felt like I was there, and it was the best thing I've ever done in the mall, still to this day. So again, my point is that this was a real experience, and I felt like I was in space shooting down Space Invaders. So my point here is technology, or virtual reality, has been around for years. It's like not a new technology. The gaming sector has definitely brought that to us, originated from them, and they've advanced the technology to where it is today. So how many of you had one of these? You've all experienced virtual reality. This is what I would like to call the first affordable head-mounted display. So now, with the advancements in technology from the gaming industry, we have a lot more options and at different price points to experience virtual reality. So for $10, you can buy a piece of cardboard. I have some Russell ones over there. You can try out later if you want, where you just put your phone in it and open up some apps, and you'll be in virtual reality. Same goes for Samsung Gear VR. It's around $100, or you probably maybe got one for free if you bought a Samsung phone and they were in promotion. Then there's higher end options in the $400 to $800 range. That's what we'll be using today as an HTC Vive. The other popular one is Oculus Rift, but there is a lot of options out there nowadays. And those get paired with a high-end computer, so you need a really good graphics card and a little bit of power. So around $2,500 gets you a decent computer. So that's definitely made the affordability and the access for us to provide virtual reality and immersive technologies as a service from the gaming industry, and it's so affordable. And it pairs perfectly with the advancements in technology for construction. So we started with hand-drawn blueprints, And then we went to 2D computer-aided drafting drawings. And now we just generally make 3D building information models. So anytime you make a change in the model, it changes anywhere it might be shown. And then there's such high levels of detail that with literally one click of a button, we can push it into a virtual reality software and view it in the headset. So now I'd like to present one of my more recent virtual reality experiences. This is IH. So the design team brought their traveling VR headset to a group of about 6 to 8 owners representatives just in their conference room. We had a meeting to look at some design options, but we went and looked in their 3-story atrium, and the user went across and we're like, oh yeah, walk across the bridge up here on the 4th floor. So he's going across and he gets to the center and we're like, hey, look over the edge. And he went to look, and with real actual fear, he's like, whoa. Like, so the sense of the space is amazing. And this is from the model that the architect and the design teams create anyways. This is the level of detail that we're using just for our regular construction purposes, construction documents. So it makes that transition really easy. And Rebecca will be going into more detail on how they're using that in the design.
Thank you, Becca, too.
Yes.
So I'd like to start by just showing a construction document floor plan. And for those of us in the industry or maybe facilities who see these, we understand what these symbols mean. We know this is how a building gets built. It's the way we communicate the information to the builders and say we want this here and here. But a lot of times in the design process, you're presenting these to people who are not familiar with floor plans. They look at this and they just see lines and dashes. And when I try to explain to them that curved wall here is actually going to be a 10-foot red colored feature in their space, they may get it, they may not. And we all have struggled with trying to communicate the design intent to the users and owners representatives of our clients. And even more confusing is when we go to a reflected ceiling plan here, and we try to explain that a reflected ceiling plan is when you put a mirror on the floor and you look down and it reflects what's up. And then I might get some blank stares and I try to explain, well, see these elements here? Those little dots are these beautiful glass balls that are going to hang from the ceiling and be this gorgeous feature. And, you know, can't you understand that? And here, you know, see this beautiful texture here? This is going to be this wonderful wood pattern, and you'll have depth and texture to the entrance of your auditorium. This is a local high school that we were working on. And so when I'm presenting this to teachers, to principals, to maybe people who have never seen a floor plan in their life, it's hard to communicate our design intent. And we bring materials and samples and pictures, and we can even do renderings, but sometimes there isn't that aha moment until it's actually built, and you get the dreaded, I didn't know it would look like that. That's not something we want to hear, because we want to make sure that everybody is knowing what is happening in that design process. There are 1,000 decisions to make during the design, and we want to be sure that our client is with us on each one. And so for this client in particular, we brought them over to our office, and we have our VR set up. And we just quickly, like Becca said, with one click of a button from our Revit software, was able to give them this. And again, there's not materials, there's not textures or colors added, but you could see the space three-dimensionally. And when you're in the headset, it's even more immersive. You can look up and see what the glass walls are really going to feel like in the space. You can walk over to the auditorium entrance and actually understand that depth and how that proportion feels. They were concerned about how high or low that curved wall would feel, and this gave them that without any really extra effort. And so in a couple-hour meeting, we were able to run through a bunch of quick design decisions that kept us on schedule. And so now we're actually going to show you a live VR demonstration. I'm going to invite Jason to come up and put on the headset. We tried to pick an example, even though we've done a lot of virtual reality that is more manufacturing based. And so this is actually a Petrolube, which is a truck service and parts center. And so although it may not look very exciting, it's very important to this client. And so you have these large truck bays, you have a part center, and the architect was trying to make some design decisions early on about what things should look like. So we're going to take a look at the option of a curved facade or a flat facade. We're going to look at stair configuration to the mezzanine. And again, this doesn't look like a lot to us, but those decisions to that owner, where the forklift is going to be able to drive through, how you lift up to the mezzanine, the function of that space is very important. So these are some of the options we looked at. And then finally, shelving configuration. Again, being a truck stop parts service center, they have big giant semi-truck tires and parts, and they need forklifts moving through, and so the shelving configuration was very important to them. So I'm going to flip over. And doing a one quick walkthrough. Does anyone have any questions? Always put that on. Okay, so Jason is going to navigate to the front of the building. He uses this all the time, and so when you start in the VR, you start out in space, and then he'll zoom in towards this. So first we're going to look at the curved facade. And there it appears, just like that. So there's the curved facade, and the importance of the curved facade to this particular client was the fact that you're coming on an interstate, and you need to attract from the interstate in that flip of a second when you're driving by, hey, come to my store. And so what would that signage and impact be with a curved facade? Could you do a better sign to attract people more? And then I'm going to show the flat one. Again, it's just a click of a button, updates, and there's the flat option. So raise of hands, who likes the curved better? A lot? Okay, anyone like the flat better? Okay. It actually ended up having to be the flat because of cost. The curved facade and the way that it worked with the roof system ended up to be too costly. And the reason why the architect tried this out in VR was to prove it out and say, okay, I don't think it made that big of a design impact going to flat. We're okay with that. And so now Jason's going to navigate into the stairwell that we'll look at. And he's using a teleporter. You can see that orange dot lets him move through the space very quickly. Yeah, he just jumps around. So this is the mezzanine here. And again, I mentioned that with the forklift traffic, they come over to the mezzanine and need to move parts up to the top. So they looked at this L-shaped stair here, which is close to the wall. And then we'll switch to one side, the exterior. And you can see how that stair is tighter to the wall, but takes up that longer horizontal run there. And he can even look back at how that is, and then we'll do the last option here. And that's the stair going the other way. You can actually move up the stair and check out how it is on the mezzanine. So any thoughts as to which design option we went with?
First one.
The first one? You are correct. And the reason for that is how compact it could be in order to allow the forklift to move in. And so again, this is proving out design and saying this is the best solution because it works for the function of the client. And finally, we'll look at the shelving area. So you can see this configuration here. The client and the architect were able to move through the shelving area, check out spacing. The beam structure in the mezzanine was a lot deeper, and so they had to be conscious of how high the shelves were and how many they could fit in this area. And then switching to the second option, and you can see the difference there. I think this is the option that they ended up with. Thank you, Jason, I appreciate it. So we'll switch back to the PowerPoint now. And if you want to, after the formal presentation, you can try out the VR on either this model or another one that we have. So moving from a basic model like that and design to just kind of prove out concepts, check spatial relationships, we can really take it to the next level. And we can add those fun materials and colors and textures and furniture that give a full immersive experience. And so some of you may be familiar with Franklin Elementary School in Moline. They had a fire last year. It was a lot of media coverage. The school students were displaced the school year. They had to find another building to use. And they actually interviewed some kids and asked them what they would want in their new school and everything. And so the school district was really great. They came to us and said, we don't want to just put the school back the way it was. It's a very utilitarian 1950s concrete block school. We've all seen them. And they said, we want this to have a really great learning environment. We want it to be adaptive and flexible and open up and have fun spaces. And so we were able to do that. But it's a lot of change. It's a lot of change for teachers. How are they going to teach? Change for students. What's their new school going to look like? And so as we're going through design, we didn't have the time or budget to actually take them into VR a whole lot. But when the project went out to bid and Russell started construction on it, we said, you know what? We have a really solid model here. Let's take a little time and add some materials and colors. Let's give them that full immersive experience. And so we were able to take this setup to the school, and we had a group of students that the school selected, and the students, the parents, the teachers were all able to try out the VR. And so this is a little video of the walkthrough, so they could actually come into the building, see their new entry with the graphics that engage them, walk down the hallway here to the new very open library, which was definitely a new concept for them. The kids were so engaged, they tried to sit on the library furniture and throw basketballs in the hoops in the gym. And so they could see the fun colors and clouds and furniture that were being planned for their new space. The graphics were a new concept for them. They didn't have something like that before. And then as you walk down the hallway, you could see the open learning environment of the art room and the flexibility of spaces that could be open to each other. And here, the teachers found most interesting this little collaboration corner outside the classrooms. And then the teachers could go in their classrooms and they look around and say, oh, I understand I'm going to have this much storage now to work with. Okay, that's where the glass wall is. I could teach like that. And the big benefit here was that there's no surprises when construction's done. And so the teachers and the students were both able to be really excited about their space. These are a few shots from that event. And they were just really tickled to death to be able to have that experience. And so we're really using VR to not only make design decisions, but to increase excitement about the project and understanding of it in a real way for marketing and community. And one other way that we're doing that for a client for Unity Point, this is a Finley pediatric, and you don't always have the opportunity to take this huge setup somewhere. What if you want something more portable? And so we can take and do these 360 views here, and that allows people, we can put this on their phone with an app or a QR code. On the back of your placemat, you actually have QR codes for that Franklin model, and so you can snap that and look around in the space in 360 views. And so this makes it very portable. You can take this to board members, to stakeholders. We've used it even in an interview process. But for here, they're actually using it for donor support. They don't have enough money yet to do this project, and so they can take these 360 views and look around them and get people excited and say, I want to be part of that. I want to donate money to that. So now Becca's going to share how she's engaging her stakeholders to get buy-in on virtual reality, or through virtual reality as well. Hopefully I didn't yeah, it's a little stuck. We were clicking on the website to show you the 360 view, and it didn't like that.
man.
It's stuck. So technology is great when it works.
Well, I can kind of talk about it still. So at Russell, we also have to get buy-in from our clients. And since we do real estate development and facilities management, we really see the project of a building throughout its entire life cycle, from idea to completion, even to facilities management. So this example is one of site development. So maybe we have an owner who needs a certain amount of square footage with a certain amount of office space placed on a site somewhere. We'll go out and select a few sites and lay something out for them and create this typical site development plan. Now with technology, we can use an app that brings you into an augmented reality. So an augmented reality is when something is overlaid superimposed is the word, onto another reality. So with my iPad or phone, I could then take a picture of this site plan and we'll scan it. And then it goes ahead and places the 3D model right on it. So then I can begin to rotate around. I can hold a piece of paper or whatever that tracker is in my hand and rotate it around and see that on my tablet or phone. So this can really help get buy-in, not only just from the client, but maybe if they were doing a large development, the community that it's going into, or maybe a zoning board that needs to approve these changes, to realize what the actual impact of this large building is going to be to the site. So that's one way we can use augmented reality. So the next thing we do a lot of is spatial coordination. So once the design is done, a whole another set of team members comes together to really figure out how this thing's going to be built. So we have subcontractors from mechanical engineering, or mechanical, electrical, plumbing, and fire sprinkler all come together, and they all also create 3D models that we can bring together and create immersive visualization of how things are going to be installed. So this really allows us to do a lot more proactive planning. And so decisions and finding issues and fixing them earlier on the computer is way less costly than it happening out on the field and 3 guys are standing around like, where do I put this pipe? This helps a lot in that aspect. And once we already do like all the spatial coordination of where everything goes, we can start looking at prefabrication or more customized fabrication methods. So maybe you need to run penetrations through your steel for a bunch of mechanical systems. The steel fabricator can detail this all out on their shop drawings and do that work in the shop. Similar, here's some other examples of modular prefabrication that can all be planned with these coordination and 3D models and visualizations. I especially like the middle one of the bathroom plumbing racks. So usually this means some guys in the field on the ground or working overhead. So when they can fabricate this in the shop, that allows them to work like more safely at an ergonomic level, not overhead, and reduces waste on our sites. So then now we have all these parts and pieces, and we have to actually build it. How long is this going to take us? So we get this very easy to read construction schedule. Am I right? No. If you're not working in construction every day, you do not know how to read this. This is called a Gantt chart. I feel like it's like a gnat, pesky and annoying. Sorry, I don't make schedules, so I can say that. But if I asked you, what's this building going to look like in the beginning of October? Can you tell me? No. So what we can do is, with our 3D models and visualization techniques, we can pair that 3D model with the schedule. You'll see the schedule on the bottom here. I know it's a little low. So now we have all these parts and pieces. We can give a better direction in a format that everyone can understand of when the concrete guys need to get that rebar on site, when our steel supplier needs to deliver the steel, when the precaster has to get out there. So it can be on this large whole project building scale, or we can go into a more micro level. So this is a mechanical room. So now we can say, okay, we need the demo guys on this day, the abatement guys on this day. Like we can break it down to a much more minute detail. Then they're gonna come in and demo out the ducts and then bring in the new ducts. So you gotta get your sheet metal fabricated in on site, and then the piping will come in. And we've also done these to even greater level of detail just about like how a wall system is going to come together. So curtain wall and flashing, waterproofing and stone and metal studs all coming together. So that really helps everyone to visualize the schedule so we're all on the same page. And we know we have to be done by this day, otherwise we're going to affect everyone else after this. Then the next thing is the actual install. So now there's technology out there with the HoloLens and the Daiquiri helmet. You can actually be in what's called a mixed reality. So this guy is standing in the actual construction site where he's gonna install this diffusers and ductwork, and he's seeing the real building around him, and then that model is superimposed so he can see where he needs to install items. So that's a really exciting thing that's just kind of come out in the last year or two. So now the guys installing in the field could actually see what's going, and we can use it as an as-built to make sure that they did install for the model and design intent, and really check for the quality in that sense. Then another one with this same mixed reality, and I even saw some examples of this sort of idea on the Quad Cities Manufacturing Hub website, is the idea of trading on site. So when he goes to install, I don't know, this is a pump, but I'm gonna call it a pump. You know, it would give him instructions on his screen and project those into the real space of what wires need to be connected to what is the actual systems to do the startup maintenance and ensure it's running properly, or maybe they need to switch out a part and it could give the instructions right there. We're already using technology somewhat similar to this for facilities management. So when we build these models, they're called building information models. So they're loaded with information that we can extract, and that can be supplier, serial number, the guy to call if it breaks down, you know, what filter size, anything like that. So they could go in and select what this is and get kind of that spec sheet on that unit of equipment.
So I'm gonna talk a little bit about other visualization tools we're using besides the virtual reality. And I want to start by sharing a story about my dad. My dad worked at a local manufacturing place for 30 years, and I was telling him about this presentation and some of the examples we were doing, and I told him about the VR and showed him some things. And he said, but when I talked about manufacturing, I was speaking his language. And he said, you mean you could model all the equipment in the warehouse and where to move it around? And I said, yeah, we do that. He said, you mean, so like if you get new equipment or you need to move something around, you could actually, in virtual reality, have all that and walk around it? I said, yes, that's exactly what we're doing. What do you think? And he said, oh, that would be amazing. And he said, when I was there, and I'll leave the manufacturer out, he said, the engineer would come and print off big CAD plans off of a plotter, and then cut out little pieces of paper of the sized equipment and place them on the plan, and they'd all gather around on the table and try to move things around. And it reminded very much of my first design projects when I was very young, and how you cut out little pieces of paper and move them around. I said, oh, we've come so far. We can really help you with this. And so the next example, again, for manufacturing that I like to share is when you have equipment extraction and replacement or removal and replacement of large pieces of equipment. We understand that a lot of times in these warehouses and manufacturing places, there's a lot in there going on. And when you're looking to replace something large, you want to make sure that there's no conflicts or be aware of them. And so this is a company that we were hired to coordinate that operation with. They had these large ball mill equipment pieces, and they needed to move them out and then put new ones in. And how would that coordinate? And so this is the process of how that is done. And then this is the video. But the way that we did this is we actually went into the space and took a 3D laser scan of the whole place. And this gave us a very accurate, what's called a point cloud, that we were able to use to model really accurately from. And so what you're seeing in the background there is a piece of that point cloud that's created from that 3D laser scan. And so we're able to then, as she said, with the augmented reality, superimpose the equipment pieces that we model into the point cloud. And this can be accurate down to 1/8 of an inch and see all that different interaction. So you can see here the first step is to lift the equipment up on saddles. And we can get those 360 views to see what that interacts with, what things are overhanging, how do you address different structural issues. And then it's put onto this rotation platform, so it's turned at a specific angle. Again, identifying where we don't want to hit that column there. When it turns, how do we have to address all of the structure? We ended up having to take out a piece of the wall in order to get this out, but we were able to correctly identify how big that hole would have to be cut and how it would come out. So then it's moved down on the track and then all the way out, and it actually got determined that in order to miss that piece, it had to come out further than first anticipated before being rotated back out. And then finally the truck comes and it's lifted onto the truck in the final view here. And so this is a way that without virtual reality, you can get these different visualization technologies to help you with your processes. Another example of this is, I'm sure you all have many facilities that may not have up-to-date CAD plans. And maybe you have a roll of drawings in the basement or a building that you just don't know what happened to them over the years. And this happened for us when we were looking at doing this brick addition onto this small building. They didn't have accurate plans of that existing building. And so the old method would have been to go out with a bunch of tape measures, draw it up by hand, measure everything out, take it back to the office, input it into the computer, and hope you got everything accurate. And if you have to travel to a site, maybe a few hours away or even a plane ride away, you get back on that plane and you hope and pray you got everything because you're not going back for a while. And so as you can imagine, that has a great deal of human error that could happen. But with that 3D laser scan, we were able to come here, scan the exterior of the building, and it's much more accurate than our human dimensions can be when we're doing site visits. And then we took our Revit model of the building addition and interposed it into that so we could see that connection and how it would happen. And you can see how accurate this is. You can see the concrete has even the cracks in the pavement that are really there. This is not a rendering, this is a picture of the actual space that's created with that 3D scan. And so you can imagine the benefit of this as you maybe don't have all that accuracy with existing buildings that you would like to have. And then we asked the question, how far can this go? What are the next steps? And so as we get further into these technologies and we're using the 3D laser scanning, we're using the virtual reality. As a volunteer project, a couple of our guys in our office took and they scanned the very famous Putnam Museum here, landmark of the Quad Cities, and they actually scanned the interior in order to get this. And with that 3D scan turned to point cloud, they were then able to extract the information and create these BIM models for the owner. And this is being used to gain community awareness, support, marketing, excitement. But this can go even further, you can see the scale of this is even larger. And so now we're actually using drones to fly over sites, buildings, landscapes, and take videos and pictures of that area. And then we're extracting out that information and creating these point clouds and then modeling from it. It just keeps going. I'm so excited to see where the technology will go next.
Yes. I hope you can realize that we're sort of nerdy about this technology. And I hope that got you excited about seeing something, you know, what virtual reality is, if you didn't know already, and how it's evolved for the built environment. And maybe if you're not in buildings, but maybe hopefully it sparks some ideas for you as it relates to your industry. As far as it goes to getting user buy-in, using it for marketing, and getting that early proactive planning to increase scheduling and on-site deliveries. So we're very excited to see where technology takes us, and
we do invite you to come up and use the headset if you're interested.
If you have any questions, you can ask them now, or definitely feel free to reach out to Becca One or myself. That completes the formal presentation now. So, any questions?
As a, I guess called a manufacturer vendor, how difficult are you seeing it to be for other manufacturers to bring in equipment for you to use and leverage? So are you able to draw everything? And are there still functions out there that you're not able to integrate into your drawing? It's difficult to make sense.
Yeah, John, do you want to maybe touch on when you have, like, for example, in ball mill, how you got the manufacturer who has all the equipment to get those equipment pieces modeled accurately?
Well, for the facility, we scanned the facility, so we had a pretty good accurate representation of that. We worked closely with the lift guys that are going to actually do the work to get the ball mill out, and they gave us some dimensions of their equipment. We built that as a model, but then we also worked to engineer the saddles. We did the structural engineering for the saddles, so that we made sure everything worked, nothing was going to break as it was going out of the building.
So you guys are fabricating imagery, I mean, based off spec, kind of that.
Yeah. So definitely the same thing goes on the construction side, even as far as like rebar and concrete. Like rebar guy doesn't follow this rebar, but sometimes it's really important to see how all those pieces come together, and if it ends up going to be all bar and not concrete. So we'll go ahead and model those like very specific things. But I think the industry has come like a long way. There's IFC file types of like industry standard format basically for file exchange. So I feel like the integration between software, regardless of what the manufacturer is using to create their models that are to their specific specs, are a lot easier to interact with each other. So we can file share a lot better now.
And from an interior side, it's gotten a lot easier. Almost all the furniture manufacturers, window treatments, and all of that have Revit files for us to use and really set up to work well. The Franklin model didn't take much time because the furniture was available from the vendor.
Yeah, so I work with a mechanical contractor. Some of the benefits that we've seen with the laser scanning and modeling. So like laser scanning, let's say it's a hard to reach place, then you don't need to necessarily set up lift equipment to be able to access and run tape measures and drop string lines, that type of thing. And then from a fabrication standpoint, you can have things accurately fabricated, and then that minimizes the downtime for the manufacturer. I mean, so you can go from what could have taken 3 or 4 days and get it done in a 12-hour window. So
that was kind of the question I had. What has this done for your turnaround time? I mean, from ideation to completion. I mean, is it more volume on your end now that you're able to do more projects? Or?
I guess I don't have any numbers or anything like that, but I definitely feel like I've worked on projects where people have said we wouldn't have been able to do this without modeling and looking at this in 3D and finding these errors with virtual mockups and things like that. While I think it could eventually be done, like you're alluding to, it would just take a lot longer. So, I mean.
And I think from our end, we've seen it in 2 ways. One, the laser scanning, you know, a lot of times it used to be how expensive is it going to be to add that service? And now we're looking at it more from, okay, instead of running all these tape measures, are we actually saving time by doing the scanning? And so that has come out to fruition for us in-house. And then the other way is, as you know, a lot of our construction timelines are getting quicker, and the demand is quicker on us to get drawings out to bid. And so when we're making those upfront design decisions, like I gave the example with the schools, our timeline was so short that using that was able to have us run through those decisions very quickly. So it's helping us on that end.
Your question about time, as we've gotten from more of a paper situation into modeling, it has been able to compress our timeline a little bit. What it's done though with the models is it forces us to do more upfront design in order to get that model sorted out so that it's more useful later on. Because we have to put a whole bunch of information into the model before we can even start doing any plans. Whereas before, with hand drafting or AutoCAD, AutoCAD is effectively a hand drafting tool in a computer. It's a 2D tool. So it was a similar process with the AutoCAD, whereas this is a completely different way of looking at things. And we can start modeling, but in order to get that modeling accurate, we have to get into the engineering in order to update the model so that we have all that information accurately in there. So it has forced us to do a lot of that engineering and design earlier on in order to get to the point where it's useful information to either the owner or the contractor.
You also see the industry trending to more design build projects, so the builder will be on board during design to kind of help with some of the decisions, and then that really reduces the kind of like the turnover time, where instead of going then to like a true, correct me if I'm saying this wrong, Brian, a true like subcontractor situation, to the design team has been design assist the whole time, and they already have all that knowledge from the design process to then carry over onto the construction and application side.
All right, I'll throw in one more piece here, but I do a lot of industrial work, and a lot of the quotations we do are a lot of hand waving. You go out there and hand wave, and you're like, hey, how do we get from here to there? And, right? So then you end up drawing a hand sketch or whatever it may be. But when you can do it with a scan, you can go in there and you can put that model right into that scan, and you can see exactly where things are going to go. You can see what's in the way. You can see how you're going to get things in and out, like you showed at the ball mill. But I mean, it's a lot more effective hand wave when you can scan it and then put the pipe right through where you need to go. Right.
What's the technology ecosystem you guys are working through now? So I've heard scanners. I've seen Revit. We use CET Configure and Revit and all steel. But I mean, what's the kind of pack toolkit that both Shive has, Russell has? Everyone kind of synergy. Is there synergy there? You use all on the same.
I think everyone's using Revit. Like at this point,
right, for construction industry, the Autodesk AEC suite is basically kind of standard. I know maybe in like different regions, but definitely for our region, they might be using MicroStation, but and ArchiCAD I think is another popular one. But for Russell, we definitely use kind of a lot of what's in the AEC suite, so Revit, Navisworks, InfraWorks, AutoCAD, and some of the 3D Max and rendering things. And we use some other renderers. I use 4D, or the scheduling software I use it's called 4D scheduling. It's made by Synchro.
And then we're using Inkscape right now as our plugin to do the VR. There are several other plugins with Revit for VR that we're testing out. John's always got his hand in a new one. Are there other software that you're using as well?
For VR, we do have Fuser, and we have a few open source options we look at. Kind of teaching ourselves on the side. The other stuff.
What about to do the point cloud?
For scanning, we use a variety of software. We go from Trimble software to Faro software. We have Faro scanners.
But then into Autodesk.
Yep.
does that translate to the job site then for project managers? Are they on a?
Yep, so we use the 360 glue to view the models on site, or we'll have the computers hooked up to the TVs in the trailer and they can view the models. Just like that. Autodesk offers a whole 360 platform. We also have a project management software called Procore that we can.
By and large, Autodesk is the standard. Folks in the government and primarily government use Bentley, use the microstation, and that would be, if we're doing a project for the arsenal, then we would be delivering that in a microstation format. Or if we're doing a bridge design, say for the government, either Illinois or Iowa DOTs, generally they want those presented in microstation as well.
And it's not to discount like other software or like more schematic software. So I've seen great stuff come out of SketchUp, and SketchUp has a free program. So people will always be like, Becca, what can I use to draw this up? I'm like, I don't know, just use SketchUp. Like, and then there's a bunch of plugins for SketchUp. Iris VR is very popular and they support SketchUp and Revit. And so you can just one-click push out of that too.
I was intrigued with your example of the pump thing. And I think of Amy, she often has people that are, you're training new people to do pieces of work and stuff. And I'm sure there's always the thing is, you know, how do we best bring a new person up to speed on doing this piece of work? So, you know, that kind of stuff where you've got something that you know you do, and how do we help a new person learn how to do that?
Yeah.
It sounded intriguing.
Yeah, and I haven't done any of that. Like that was part of my up and coming stuff, but that's like a new technology that's come out in the last year and a half. Have you done any?
Well, okay, so I'll share one more thing, right? But I was done, but so one of the things that we see with the technology are smart models. So you put the information in the tag system. Let's say there's a valve or something that opens up so that the air handler will work properly. Well, then you walk through the building and you can see where that ductwork is. You can see where that valve is. You can see that tag number as you're walking through the space. So if you've got a clear set of AR type glasses where it's augmented reality. So we see that as the future. Or if you have a service technician, there's less and less people, right? 20 years ago when you worked on a car, everything was kind of point to point and just straight wires, right? Now everything's all computers. So these service techs, they're working on the equipment, they can do the point-to-point stuff, right? They're pretty good at that. That's pretty mechanical, but the computer is a lot harder. But they can, the thought process is they can do a kind of like a Skype video with somebody on the other end, and they can see exactly what you're looking at, and then they can give you certain pieces of information through those glasses. So, I mean, that's where we think it's headed.
Yes, thank you.
And also, same sort of thing for buildings with owner's manuals becoming virtual. You have it within the iPad, and you can call up the space, show the image of it, or point it at your room, and then be able to identify what the equipment is, pull up the owner's manual for that equipment, and understand what the maintenance requirements are for things that way as well. Ultimately, that's where it's going to go. We're not quite there yet.
What's a typical cost for a scan like that?
That depends on the complexity. By and large, we try and do a 25-foot by 25-foot grid. So if we're doing a manufacturing facility, it's going to be about 10 to 15 minutes per scan, depending on how large the space is. As the building gets taller, the longer the duration of the scan, because of the distance you have to be able to shoot the laser in order to be able to get dense enough information. Typically, for a building, maybe a floor of this size of this building, because we're going out into the hallways and that sort of thing, it might be a day's worth of scanning for this level of building. So that would translate into between that day and a day back in the office to stitch everything together, get it to be useful. Talking about somewhere around $2,000, $2,500. So in order to be able to do that, we can spend that amount of time, whereas before John and I might have to come along and then we're pulling the tape. We're spending about the same amount of time and we're getting maybe 0.1% of the information that we're getting out of that scan. So it's very much worth our while, worth our time, worth the owner's time to invest in that. And it's a lot more useful data for everybody.
It also kind of depends on the density of the scan you're looking for. If it's presentation quality, it takes a little longer to do scans. We now have handheld scanners where if it's a really super quick floor plan you're just looking for, you can walk around the space in half an hour and get a pretty good floor plan.
And we have a couple of different systems in the Moline office. We have a much older scan that is still useful. I think it's a Leica, but it can do longer distance exterior scanning. We have Faro, I think, in the office as well that is more useful for interior spaces. You're not having to collect data from as far away. And our Cedar Rapids and Des Moines offices have similar systems to that. Our Iowa City office actually has a handheld scanner where they walk through the space with the thing on a stick, almost like a selfie stick. And it's a lot quicker, not quite the accuracy of the information, but you know, maybe you don't need it to be accurate to less than a 32nd of an inch all the time, right? And there's enough information there to be able to bring it into the Revit model and be able to manipulate it that way and get started much more quickly.
Anything else? Well, thank you for having us.